Good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on Ohm's law. So let's discuss the worksheet. So here is the worksheet. The first question is, what is Ohm's law? So Ohm's law is that current is proportional to the potential difference, or in a way we can say that V is proportional to I. So we can write it as V is equals to I into R, where V is the potential difference across a ohmic resistance, R is the resistance, and I is the current through that resistance. Next question is graph between V and I. So the graph will be a straight line, and the slope angle theta can be calculated as tan theta is equals to V by I, which is equals to R. In another question, there are three graphs given, 1, 2 and 3. So we can see that theta 3 is greater than theta 2 is greater than theta 1. Since resistance is equal to tan theta, so larger theta corresponds to larger resistance. So we can say that R3 is greater than R2 and R2 is greater than R1. The next question is maximum resistance is shown by, the maximum resistance is shown by graph 3. Next is minimum resistance is shown by, so minimum resistance is shown by graph 1. Next is arrange resistances in ascending order. So we can say that R3 is greatest, R1 is least. So the order will be R1 less than R2 less than R3. Next is arrange resistances in descending order. So we can say that R3 is greater than R2 greater than R1. Next question is maximum conductance is shown by. So maximum conductance corresponds to minimum resistance, which is shown by graph 1. Next is minimum conductance is shown by. So minimum conductance is shown by maximum resistance, which is corresponded by graph 3. Next is we are being given a cylindrical resistance. It has a radius R, cross section area A and length L. We need to find resistance of this particular structure. So resistance is rho L upon A. So area is pi R square over here. So resistance will be rho L upon pi R square. Next is on what factors resistance depends. So resistance depends on temperature, nature, shape and size of the resistor. Next is on what factor resistivity depends. So resistivity depends on nature and temperature. Next is a material has resistance R at temperature T1. Temperature coefficient is alpha. We need to find resistance at T2. So let the resistance is R2. So we can say R2 is equals to R1, 1 plus alpha, T2 minus T1. So that will be resistance over here. Next is find change in resistance. So change in resistance is R2 minus R1, which will be R1 alpha, T2 minus T1. Next is fractional change in resistance. So that is ratio of R2 and R1, which will be alpha into T2 minus T1. Next is percentage change in resistance. So that will be fractional change into 100. Next is we are being given a cylindrical shell having inner radius R1 and outer radius R2. Then we need to find the effective area. So effective area is pi into R2 square minus R1 square. Next is we need to find resistance of this structure. So resistance is rho L upon pi R2 square minus R1 square. Next is conductance. So conductance is 1 upon resistance. So that will be pi R2 square minus R1 square by rho L. Next is we are being given a cylindrical shell of radii R and 2R and thermal conductivity K1 and K2. First question is resistance is. So let resistance of the two are R1 and R2. We can see that these two resistance are in parallel. So equivalent resistance will be R1 R2 by R1 plus R2. Next is conductance. Conductance is 1 upon resistance. So on reversing this we have 1 by R1 plus 1 by R2. Next is effective thermal conductivity. So it is K1 plus K2 into 3 by 4. It is solved by using the fact that equivalent resistance of this, which is R1 R2 by R1 plus R2, is equal to the resistance of the equivalent rod. So on comparing both sides we get this result.